Hello, hi everyone, and this is Ganesh, and in this video I'm going to explain about the relation between coefficients and zeros of the quadratic polynomials. It's not equation, sorry, polynomial. And also we'll do a few problems based on this. At the same time, if we have zeros, then how can we find the quadratic polynomial? So such kind of things we are going to learn. So before that, I want to inform you that please subscribe this channel and share it to others. The reason everybody can get all these things, and thank you. And here the general form of quadratic polynomial is ax square plus bx plus c. So generally the polynomial, the degree of the polynomial is 2, then it is quadratic polynomial. We all know that. And here a is the quotient of x square, b is the quotient of x, and c is the constant term. Maximum terms are there in the quadratic polynomial is 3 and minimum 1 also it may be. That means, for example, x square, only x square is there, it's a quadratic polynomial. So one term, minimum, maximum 3 terms we can write in the quadratic polynomial. And here if this is a quadratic polynomial and a b coefficients and c is constant, we can say. At the same time, here two more things, alpha and beta, these two I am taking as zeros of the polynomial. That means these zeros, if we substitute in the given polynomial, will get 0 is the value of the quadratic polynomial. That's the reason these zeros are very important. And here two things we have to learn. If the quadratic polynomial is there, how to find the zeros of the polynomial, that we know that by splitting the middle term, or otherwise one identity also there, we can use it. And second thing is, if we know zeros of the polynomial, we can find the quadratic polynomial. So how can we do all these things? Let us see. First, what is the relation between coefficients and these zeros we'll see. And here sum of the zeros, that means alpha plus beta, if we add the zeros, that is equal to minus b by a, Here b is what? B is the quotient of x, middle term quotient we have to write, and a minus sign is very important, divided by a is the quotient of x square. So this is the first relation. And the second one is product of the zeros, alpha into beta is equal to, if we multiply the zeros, that is equal to c by a, where c is constant of the polynomial and a is the quotient of x square. So these two are the relation. Generally the questions, they'll give one quadratic polynomial and find the relation between zeros and coefficients. So these two we have to check it. Let us I'll take one example, by that easily you can understand. This is the given question. It's a quadratic polynomial. The question is verify the relation between zeros and the coefficients. That is the question. So from this, first we have to find coefficients. Anyway, coefficients we can find it. The given polynomial exactly we have to compare with the general form of the quadratic polynomial. Now if we compare, a is equal to 1 because x square quotient is 1, and what is b? B is equal to 7, middle term x quotient is 7. If minus 7 means minus 7 we have to write it. And the third one is c, constant term 10. So anyway, by observing the given quadratic polynomial, directly we can find a, b, c coefficients. But how can we find their zeros, alpha and beta? How can we find it? Yes, by splitting the middle term we have to solve, we can find the zeros. Now here x square plus 7x plus 10, for this polynomial we have to find the zeros. Yes, for that the last term, for the last constant term, find the factors. 2 5s are 10, we know that. Now the middle term, how can we write it? If we multiply these two, we must get 10, and if we add these two, 7. Yes, 2 plus 5 is 7. So according to that, x square plus 2x plus 5x plus 10, 5x plus 10. So after writing this, we have to find the zeros. For that, select two terms from this, take out common x. If I take common, x plus 2 is left, and here if I take 5 common, x plus 2 is left, and x plus 2 is the common thing, so x plus 2, and remaining things are x plus 5. So by this, now we can find the zeros. So how can we find it? So x plus 2 is equal to 0, then x equal to minus 2, and here x plus 5 is equal to 0 and x equal to minus 5. So here alpha is minus 2, 1 0, and beta is minus 5, second 0. So two zeros we got it, alpha and beta, and even ABC also we know ABC values. Now after finding ABC values and alpha and beta, then we have to verify the relation. The relation is what? Generally here alpha plus beta is equal to minus b by a. Now substitute the values. Alpha is minus 2, already we know that. Beta is minus 5, that equal to, here what is b and what is a? Here b is 7, a is 1. Substitute the values. B is 7, that means minus 7 by 1. Now minus 2 minus 5, how much? Minus 7. Here minus 7 by 1, minus 7. Yes, these two are equal. So the first thing is verified. This one is verified. Another one is alpha into beta is equal to c by a. So how can we verify this one also? Alpha is minus 2 into beta minus 5 is equal to, what is c? C is 10, a is 1, c is 10, so 10 by 1. So minus 2 into minus 5 plus 10, that equal to 10 by 1 is 10. Yes, this is also verified. These two are equal. That means alpha plus beta, alpha into beta is equal to c by a. In this way, we can verify the relation between zeros and coefficients. This is the way of doing the problems. And the next thing is, I told you, if we know the zeros of the polynomial, how can we find the quadratic polynomial? For that, this is the one formula kind of thing we are using here, where k is constant. Here k is any constant number, and here x square minus alpha plus beta, sum of the zeros we have to know, and alpha into beta, product of the zeros if we know, then we can find the polynomial. Look at here alpha value to beta value minus 1. So alpha beta zeros we know, then find the quadratic polynomial. For that, just simply substitute these values here in the given equation. So first k value we don't know. Finally I'll tell you what is k value, and here x square. Anyway, x square, one variable we have to take, that is x square, minus alpha plus beta. Alpha is 2 plus beta means minus 1 beta value into x, plus alpha into beta means 2 into minus 1. Substitute the values. Then again x square, here 2 minus 1, 1 only, so minus x, 1 we are getting anyway, and 2 into minus 1, minus 2. So it's over, simplification is over inside the bracket, but we didn't get any denominator here, that is 1 only. Therefore here what is the constant? K is 1. Then if we substitute k value 1 here, then finally we are getting 1 into the same polynomial is x square minus x minus 2. So in this way we can find the quadratic polynomial if we know the zeros. I am taking one more example here. If alpha and beta zeros are in fractions, then what we have to do? Yes, same thing, we have to substitute the values first. K into x square minus alpha plus beta means 1 by 2 plus 3 by 2 into x minus alpha into beta 1 by 2 into 3 by 2, that is equal to k, here x square minus, so 1 by 2 plus this how much? Generally 2 is the LCM here, so 1 plus 3, 4 by 2 x minus, here 1 3 is a 3, 2 2 is a 4, 2 2 is a 4, And now here I can cancel and everything. So before that I'm going to find the LCM for all these things. Here LCM is 4 for all these things, all the three terms. So here if I write 4 here, 4x square is there, and here 2 2's are means 2 4's are 8x, and here minus 3, already 4 is there means. Now here k I am writing directly. So before that just here finally I got 4 is the denominator, 4 is in the denominator. That's the reason I'll take k value is 4, k value constant is 4. So you remember one thing, whenever the denominator is any one number, that is the constant you have to take and multiply. If k value 4, with 4 we have to multiply, then what happen, we have 4 and 4 gets cancelled. Finally we get 4x square minus 8x minus 3 is the answer. Minus 3 is the what is that, our polynomial. And here I have to take plus, in the formula already plus is there. So finally I got this is the answer. I hope you understand well. You can solve these kind of problems by observing this video, and thank you very much. Please subscribe and share it. Thank you.